Alrighty, so this is where we finished up the last lesson. We created and finished up our class. We have stored properties, we have property observers, we have computed properties, and three separate initializers and a method that changes the salary. All right, so now let's go ahead and talk about structures. All right, so way back a few lessons ago, we said that classes and structures are general purpose, flexible constructs that become the building blocks of your program's code. We define properties and methods to add functionality to your classes and structures by using the already familiar syntax of constants, variables, and functions, all right? So now let's create our first structure. And structures are commonly referred to as simply a struct. Okay, so to do that, all we got to do, I'm going to just kind of give us some space here to differentiate between our class and our struct. We're going to continue with our developer example, and we're just going to create a version of our developer class as a struct. So I'm going to say struct, and you can see that we have it available right here, struct. We give it a name, just like with a class. I'm going to call this dev struct, okay, to indicate that this is our version of the developer class as a struct. Structs also utilize stored properties, so let's go ahead and give this struct some properties. We can say var first name of type string, var last name of type string, and var salary of type double. Now with classes, we would either need an initializer or to provide default values for these stored properties. Structs, though, they have a nice default initializer. Okay, so I can say var dev struct is equal to dev struct, and you'll see here we have a constructor already ready for us that we can initialize the stored properties. Okay, so I can go ahead and set all of this. I can say Johnny B, or Johnny, and then last name is B, salary, $10. All right, so now we have created an instance of our struct, our dev struct, using the default initializer that comes with structures, which allows you to initialize any of your stored or all of your stored properties at once. So that's actually pretty nice, especially if your struct that you're creating, all you need is something to just hold some data. This becomes very useful. So even though we have this default constructor available to us, we can still use the custom initializers that we were working with in our class. So I'm going to go ahead and I'm going to just copy these just to illustrate. And I'm going to put them into our struct here. And you'll notice that we now get an error, okay? And this is because once we add any of our own custom initializers, we lose that default initializer that we were just using, okay? So now we have to use either this initializer that sets them to these default values, or we can use either of these two initializers. Computed properties as well as property observers also work the same. So I'm going to go ahead and copy our property observer salary example as well as position here, and the monthly salary computed property. And I'm going to replace all of that right here. Okay, so all we did was we are adding our position variable, which we were looking at when we talked about our property observer on our salary property, and our computed property, our monthly salary. Okay, and we can go ahead and use those computed properties, and we can say first name is Johnny, last name B, and salary 100,000. And then we can say print, and we can say dev struct dot monthly salary, and we can run that. And we should get here the monthly salary as expected. All right, so far, these are pretty much exactly the same, right? The only difference we've seen so far is that with a struct, you can actually just have your stored properties and then you get free a default initializer. But the rest of this is the same. Computed properties work the same, property observers work the same, you can have initializers. So let's take a look at our method, right? So we have this function here, I'm gonna copy it, and drop it in our struct down here at the bottom. And we will get an error here. It says here that the left side of mutating operator isn't mutable. Self is immutable. So now by default, we are not allowed to update property values within a method of a structure. If we want to modify a property, we can opt into what's called mutating behavior for that method by adding the mutating keyword before the func keyword of the method declaration. So we can click on this and we can say, yes, mark this method as mutating to make self mutable. Okay. And in programming, mutating or mutable simply means that it is changeable. So for instance, when you declare something as a let, a constant, you would be saying that that is immutable. When we declare something as a var or variable, then it is mutable. So now the only differences so far are that if you want a function to modify or mutate a property, you have to mark it as mutating. And then we also have the default initializer for stored properties that we saw. But there's one more thing. If I were to make this a let, and then I tried to change something, devstruct.firstname is equal to Billy, now we are going to get an error. And this is that cannot assign to property a let constant. Kind of the same thing as this issue right here. This has to be a variable. So there you have it. We have our developer class, and here we have our developer struct. Very similar. There are, however, some important differences that we're going to be covering in the next lesson. But for now, let's just summarize real quick the similarities, all right? So both use properties, both stored and computed, both use methods, both have initializers. However, a difference is that the structs have their own default initializer if you have stored properties. And both use subscripts, or in other words, the dot syntax. So this is a subscript to access and set properties. All right. So there we have it. Those are the similarities, how to create a struct. And in the next lesson, we're going to be going over some of those important differences and when to use a struct and when to use a class. All right. So I'll see you there.